Okay, students, on this page we're going to graph linear and absolute value inequalities. So remember, absolute value, we know, graphs into a V. Absolute value graphs into a V. Either up or a V that opens down. Remember, from the last section, if it's inside the absolute value, and therefore it's right next to the X, that shifts it left or right, and we always do the opposite operation. So the opposite of -1 is +1, so that would be right 1. Okay, in the prior lesson, our coefficients out front were always just 1. Well, now we're changing it. So this makes it a slope of 3 instead of 1 as it was before. So it makes it steeper. Okay, again, you can go ahead and plug these in your graphing calculator to check as well. So it says go right 1. Remember, there's nothing on the bottom, on the back here for going up or down. If it was a plus or minus outside the absolute value, then that would shift it up or down. That's really just a +0 if you want to think it. So it's not moving anything up or down. It's only going right 1. So there's my right 1. Now instead of a slope of 1, we have a slope of 3. So that means up 3, 1, 2, 3, right 1, and left 1. And then I just go ahead and draw my V there. Now, since it's, you learned this from last lesson, since it's solid right there, I mean an equal sign, then I write the word solid. So it's a solid V as you see here. Okay? And then it's less than, that means it's below. We shade everything below. Again, I could test a point. I could test 0, 0. Remember, 0, 0 is the easiest one to test. If 0, 0 is true, then I'm graphing or shading all outside. So I plug in 0 for here and 0 for here. 0 minus 1 is -1. The absolute value of -1 is +1. Times 3 is 3. Is 3 greater than or equal to 0? Yes, it is. So therefore, it shades on the outside. Okay, if you didn't know, less than was below. And know what side is below. I can always test a point. The easiest point to test is 0, 0. Okay? All right, so that is that side. And just so you know, for a trickier little situation, when I said up here that it's, since this is -1, I go opposite. That's because this right here was a 1. So they didn't give you an example, so I'm going to show this as I'm seeing it here. Notice this is 2x minus 1 inside. So really what I need to do, and I can do this for every one, is I set what's inside the absolute value equal to 0. 2x minus 1 equals 0. Add the 1 across, divide by 2, x is 1/2, positive 1/2. That's really a shift right 1/2, not 1. I'm not just taking that now because I have to solve that, so that equals 0. So I'm actually shifting it right 1/2, and then the slope here is 2. So I'm going up 2, right 1, up 2, left 1. Okay, and it's solid because it has this and shaded below. Okay, so if you forget that, again, you should always check it. So again, since this is here, I set the whole thing equal to 0, x equals -1, so that means left 1. Okay, but don't forget, when I go ahead and solve for y, I got to solve for y. This now comes over to this side, and I'm going to divide by 2, so I have -1/2. So remember, the negative makes it open down, and then all the slope is -1/2. Down 1, right 2, down 1, left 2. Okay, you can always check these by putting them in the graphing calculator. Okay, so let's go ahead and just do that for number 2. Y equals, let's see, what was the equation? Inequality again here. Absolute value of 2x minus 1. Absolute value of 2x minus 1. Okay, and that was it. So delete that. Okay. And just so you know, in the graphing calculator, if I want to shade below, Move it over here, hit enter. That's the color. We want to go to the next one down. Hit enter. Oops. Let's go back up. Let's see. Go left or right. Left or right as I hit. Okay, so that means shade above. That means shade below. So ours was below. So now we go ahead and hit enter. Okay. So now it has that and hit graph. And there you go, right there. Okay, now if I want to find out where that vertex is, or I can hit table. Table. Why is it table going here? Oh, second table. Sorry, second graph is table. Okay, it's going by ones here. If I want to change it, the window, and at the window of the table set, second table set, and go by 0.5, 0.5 instead. Remember, we're saying it's at 0.50, so you need to go by 0.5s. Second table. Notice at 0.5, it's 0, like I had said. Okay. And there we go. And it was a slope of 2, so we went right 1, 1.5, up 2, and left 1.5, or left 1, up 2. So we get negative 0.5 and up 2 at 2 right there. Oops. So you can see that's graphed correctly, like I had said. Okay. That's page 1. Page 2 now. We are solving systems by graphing. Okay, that means if it's in standard form as it is here, I can use the x and y intercepts. Okay, solving a system, I'll find the point of intersection. Find point of intersection. Okay, so if I do x equals 0, y equals negative 2. If y equals 0, x equals 4. So you see 4, 0, and 0, negative 2 right there. Graph that line. The second one, x is 0, y is negative 2, and y is 0, x is negative 2. Okay, well, obviously, we already can see our point of intersection. They both go through 0, negative 2 right there. Okay, so that's using the, since they're in form, that's using the x and y intercepts to graph the line. You could have also solved each one for y, okay, as they did here. They solved each one for y and put it in slope-intercept form and then graphed it from there. I don't care which way you do it. Okay, your choice. Slope-intercept form. So if it's in, gives it to me in slope-intercept form as 1, 2, 3 are, I do it that way. 4, 5, and 6 are almost in standard form, so I would do it that way. Unless, for example, here you see negative y, positive y, negative y, negative y. I can just quickly move this across, move this back across, and I have it solved for y. So that's real quick. Moving that over there, and it's in slope-intercept form. Okay, so in that case, that would be easier to put it in slope-intercept form when it's got a negative y or a positive y. Since this is positive y, I'm moving this term across, and then I'm done. Y equals negative 1/2 x plus 1. Okay. On 5, if I want to get rid of the fractions, I multiply the entire equation by 3. We talked about this before. So I have 6x plus y equals negative 21. And then subtract the 6x across, and I have it in slope-intercept form. Okay. Now, in that case, it took you off the graph, so you'd have to plot the points that were on the graph in this area right here. All right, that'll do it. So, to summarize, we did graphing. We solved systems by graphing, and we graphed absolute value, linear and absolute value inequalities.